Hi, this is Vinoth Manamala. I'm a data scientist with TIBCO. Today I'll be walking you through the Python data function feature with this demo. This feature will enable the Spotfire users to execute Python scripts within the Spotfire DXPs. So there are two main requirements for this feature to be enabled. First, we need a Spotfire 7.13 client and above versions, and a Spotfire server to install the packages. Second, we need a Python IDE installed in your local environment and the Python executable file path listed in your path environment variable. By doing this, the Spotfire can automatically detect your Python version in the data function script tab, which I'll be showing you in the meanwhile. Now let us take a look at the data we'll be using for this example. So this is a manufacturing data from a fossil fuel-based industrial furnace. There are 5 plants, and we have 5 product lines within the plants. And for differential pressure, we have like 6 sensors within the product line, which will record data continuously. Here, we're going to use TensorFlow library, and we're going to call the neural network algorithm to perform anomaly detection. So in this case, we're going to check if emissions, for example, nitrous oxide or carbon monoxide emissions, are okay or anomalous for specific high loads. And we're going to ingest the results from the neural network algorithm into a visualization for further exploration. So let us see how this feature works. Building a Python data function is very similar to building a data function. For example, first, we define the input variables in your input tab, and you define your output variables in your output tab, which is very similar to the data function. So once you define your input parameters, you could start using those input parameter variables directly into your scripts. And you can just store your results into your output parameter variables. So you could bring back the output as a table or as a value or as a column. So the Python data function supports all 3 data types. That is very similar to the data function. And like I said before, the Python data function can automatically detect your Python versions that's listed in your home path variable. The Python data function supports all versions of Python. In this case, we have tested this feature extensively on Python 2.7 and Python 3.5.2. Now coming back to the scripts tab, it's very important that we include this line of code before you start coding in Python. This should be your first line of code. This is just in Python data function package, or the boilerplate code as we call it, and it has 3 main functionalities. First, it helps the Spotfire to communicate with your Python IDE. In this case, it could be a vanilla Python or an Anaconda version of Python. Second, it helps to ingest the user inputs that's defined in your input parameters tab into the user code. Third, it extracts the output from your user code and brings it back as a table or a value or a column data type that can be used in your Spotfire dashboards. And rest of the code here is a normal Python script. In this case, we are just importing TensorFlow library, and we're using the neural network algorithm, and we're performing anomaly detection on our data. Basically, this is just in TensorFlow lower level API to just call the neural network algorithm. Now let's close this dialog box. And I already run this model since it takes a lot of time. And as you can see, the results from model are being displayed here as part of the visualizations. So now coming back to the reconstruction error, any values within the bins that have a score more than 1.0 are termed to be anomalous. So I'm going to highlight these anomalous points, and I'm going to see the reconstruction error over the time. And we can clearly see when these anomalous activities happen over the time as part of this manufacturing process. So we could go back to this data points and check what is wrong with the control parameters and tune them to make sure that it just never happens. And we can also see the loss versus steps. Basically, this particular visualization explains how the model has improved as the epochs have progressed. For example, we start with the 0th step, and as you can see here, as we progress towards the final epochs or the final steps, the loss function keeps reducing. At end, we have a very good model. Now, coming back to the analysis dashboard, you can see the reconstruction error by column for all the variables. In this case, I'm looking at the 6th differential pressure, and you can see the reconstruction error by each column and how they contribute to this particular analysis. And not only that, we can see the actual versus the predicted values. So these are the actual values as part of the data set. And these are all the predicted values that have been returned by the neural network algorithm, which is part of the TensorFlow library. So this is Python data function for you. Have fun. Any questions, please feel free to email me. Thank you.